Section 2.3, Part 1 video. Before I begin this section, let me just, by way of introduction, mention just a couple of things. First, probably of all the sections we cover, this is the biggest one that we cover of the semester. It'll probably be the one that has the most videos. So it may take you a little bit longer to get through this section, which is one of the reasons I encourage you to try to work ahead in your video watching and also in your homework. So, also in this section, there's going to be a little bit more things that's a little bit more abstract, a little bit harder to kind of get your hands on, if you will. So it'll be very important that you take really, really good notes in this section. And make sure that you write down all the definitions that I give you. That will be very important as well as taking down all the examples. So, a lot of stuff in this section. It all ties together, but it's just going to take me a long time to get through this one particular section. Okay, so what I want to do with you first is I want to start out with the definition. And the definition that I want to give you is the definition of what we call a relation. So write down this definition here. Remember, you can pause the video at any moment. Here's the definition. Here's the definition of a relation. Any way in which a set of ordered pairs can be represented. Okay, so any way in which a set of ordered pairs can be represented. All right, take down this next note. Title this next note, 3 examples of relations. 3 examples of relations. And then pause the video and write these 3 right here down. Okay, so a relation is any way you can describe a group of points. Now, when you represent a group of points, you don't have to just write the points out. A group of ordered pairs can be represented multiple ways. For instance, one example of a relation is just a set of points. So, that right there. You want to pause the video and write that down. So what you're looking at right here is a relation because it's a group of points. Now, how many ordered pairs is in there? Strictly just however many I wanted to put. Excuse me. I could have put 2 ordered pairs. I could have put 5,000 ordered pairs in there. So this is a relation. But a graph is a relation. Now, why is a graph a relation? Because what is a graph made up of? I used a circle because we just finished talking about circles, but I could have drawn any picture up here. But why is this circle a relation? Because a circle is a collection of millions and millions and millions of what? Ordered pairs. But not only that, an equation with 2 variables. Now, why is an equation with 2 variables a relation? Because an equation with 2 variables, remember, has ordered pair answers. It has an x and a y that makes one answer. Matter of fact, if you look at this right here, you should recognize this. This is the equation of a circle. The center is at 0, 0, and the radius is square root of 25, which is 5. So this is an equation with 2 variables, and an equation with 2 variables has ordered pair answers. And if you graph those ordered pair answers, you have to plot all of those ordered pairs, and a group of ordered pairs is a relation. So if I was to ask you which of these 3 right here that you're looking at, which of these 3 are relations, your answer should be what? Yes, it should be all of them, because all 3 of these are ordered pairs, collection of ordered pairs. All right, now don't write this down yet. What you're about to hear now, and you're going to hear this a whole lot in this section. You're going to hear find the domain, find the range, and the word function. You're going to hear those words. Find the domain, find the range, and function. And what we're going to do is I'm going to ask you to find the domain of a relation. Find the range of a relation. And then the third question will be, is the relation a function? Those are the three questions. Now, which of these three right here are relations? All three. So, here's what I'm about to teach you. I'm about to teach you how to get the domain of all three of these, the range of all three of these, and how to determine if any of these three are functions. But what I'm going to do is I'm not going to do it all at once. We're going to first start out with ordered pairs. And I'm going to give you some notes on ordered pairs, and we're going to look at domain, range, and function of just ordered pairs. After we finish that, then I'm going to draw a bunch of graphs. And we're going to do domain and range and function of the graphs. And then after we do that, I'm going to give you some equations and do domain, range, and function for the equations. So we're going to do all three of these things in each of these cases. So these three questions with this, these three questions with this, these three questions with this. So that's really 9 different things if you look at 3 with each one. But we're going to do ordered pairs first, then we're going to do graphs, then we're going to do equations. All right, so let's start out and look at first ordered pairs. So that's the first thing we want to look at. All right, before we start, I've got to give you 3 notes. The 3 notes goes with domain, range, and function. All right, take down this note for ordered pairs. That's why these notes are very important that you write these down and that you study these notes. All right, here's the first note. The domain of a set of ordered pairs is the list of all first elements in every ordered pair. Okay, next definition. The range of a set of ordered pairs is the set of all second elements in every ordered pair. So in other words, if you're looking at ordered pairs, the domain is all of the first numbers. Or you could say all of the x's. The range is all of the y's. So the domain is all of the x's that's used in the ordered pairs. The range is all of the y's. Now, one last definition, and then we'll look at some examples. Take down this last definition. A set of ordered pairs represents a function, and underline the word function, if every first element is paired with exactly one second element. Now, I know that sounds a little confusing, but it's really not. Let me explain to you. So just listen while I talk about this for just a second. It says think about ordered pairs, every first element. So every first element is every x. So every first element is your x value. Your second element is your y value. I'm getting my thoughts together on how to say this. So every x is paired with exactly one y. Now, there's a difference in 1 and exactly 1. Let me explain the difference. Let's suppose I had some money in my pocket and you said, Mr. Trainer, do you have $1? Or if you said, Mr. Trainer, how much money do you have? And I say, I have $1. And then I lay my wallet down and you pick up my wallet and you open it up and I have $7 in there. And you say, well, Mr. Rainey, you lied to me. You said you had $1. I do have $1. I didn't lie to you. I have 6 others, but I said I have $1. When I say I have $1, that means I've got $1, but I may have more money than that. But if I say I have exactly $1, that's different mathematically. Because when you say I have exactly $1, that means no more and no less. So let's look at what that note you just wrote down. Every x is paired with not one y, exactly one y. Here's what that means. If you have the ordered pair 7, 4, 7, 4, x7 is your x and 4 is your y. If 7 is paired with 4, 7 can never be paired with any other number ever again. So in other words, it means this. If 7 is paired with 4, you won't have 7, 4, 7, 12. So that whatever that first number is, it can never be paired with any other y value. Now, if you have 8, 3 and 10, 3, that's okay. Because 8 is paired with one number 3, 10 is paired with one number 3. That's okay. So basically, this is what you need to know. With a function, no two ordered pairs can have the same first number. They can have the same second number, but they cannot have the same first number. And so, and let me say this, because sometimes when I'm doing ordered pairs, I said this is your x, and this is your y. I'm used to students looking at me instead of watching the video. So if I get that backwards, I'm doing it backwards because I'm used to teaching it backwards as students look at me. So x is your first number and y is always your second number. So I guess I need to do it this way. X is your first number. If you're looking at an ordered pair, this is your x and this is your y. But again, I'm used to saying that backwards. But anyway, so let me say one more time. In a function, no two ordered pairs can have the same first number. The x's cannot repeat. The y's can, but the x's cannot. Okay, write these instructions down. And I'm about to put up the 3 examples, and I'll let you copy those, then we'll go over them together. So write these instructions down. For the following, determine the domain, range, and determine if the relation represents a function. So get the domain, get the range, and determine if the relation is a function. All right, what I'm going to do, as I often sometimes do, is I'm going to uncover the problem. All I want you to do is copy the problem down. Then we'll come back and go over it. And remember, you can just pause your video. Make sure that you've got all of this one on there. Not quite. Okay. Pause the video now and copy this one. Okay, leave about 3 or 4 lines under that one blank. I know this picture looks confusing, but draw this picture. Pause the video now. Okay. So let's do these 2 examples now. So on this first one, and remember, you can pause the video if you need to. The domain is simply all of the first numbers, 5, 7, -3, -5, and 10. There's the domain. And the range is all of the second numbers. 2 comments. Number 1, the order you write them in does not matter. Number 2, if you have a number in the domain listed twice, you don't have to list it twice. For instance, in the range you got -3, 4, 0, 4, but you've already put it in there. So if it's in the range, it's in the range. You don't have to write 4 down twice. And then 10. Now the next question is this relation, because it is a relation, it's a group of points, is this relation a function? Now what is a function? Every x, every first number is paired with exactly one second number. So right here, the number 5 is paired with -3. Now, do I have 5 listed again as a first number? No. 7. Do I have 7 listed as a first number again? No. So basically, do any of the first numbers repeat? If none of the first numbers repeat, then yes, this relation is a function. You say, now wait a minute, the 4s repeat. The 4s are the y's. That's the range. That's okay. It's the x's that cannot repeat with a function. And I would also write the reason why, just so you'll remember later why you said yes. And not only that, probably on test, I will ask why. Okay, now, this next example. This is what we call in mathematics, called a mapping. It is just simply this. It's a fancy way of writing ordered pairs, is all it is. Like I could put an X above this and a Y above this, and it's the same thing. So here's basically what this is. This is 5, 4, 5, 2, -1, 3, 6, 2, 2, 4. So this is all of your first numbers. This is all of your second numbers. So this is simply your domain. That's your range. So the domain range. And remember again, you can pause the video if you need to. So the domain is 5. 5, I've listed it, -1, 6, and 2. And then range, 2, 4, 3, 2, I've already listed it, 4, I've already listed it. Or you could just say here's your domain, and there's your range. So you don't have to write it out as ordered pairs. Now, is this one a function? No, because you have an x value of 5 that is paired with 2, and an x value of 5 that is paired with 4. So you have one x value paired with 2 y values. So no, that relation is not a function because the x's repeat in your ordered pairs. All right, so let's go back to our picture we started off. Remember I told you a while ago, we're going to do domain and range and function for ordered pairs. We've done that. Now what we're about to do is we're about to do it with graphs. I'm at the end of the 20-minute mark, but what I am going to do, since you can pause the video, I'm going to put up all of these graphs. I want you to pause the video and copy the graphs, and then I will give you the notes that you need for it in the next section. So now I'll tell you what, let me just go ahead and stop the video now, and I'll start with Roman numeral number 2 with graphs in the next video.